Hello, welcome to the Rhapsody May webinar. Today you've joined us for a conversation about the importance of semantic interoperability in building healthcare AI. So if you've joined one of our webinars before, you know the shtick, but I'll go ahead and go through a few housekeeping items. This is a live session and it is being recorded. Anyone who registered for this event will receive a link to the recording within 24 hours. If you have any questions, please bring them forward. Don't hesitate to ask, just throw them in the chat. We'll do our best to answer your questions during the session, and if we don't get to it, we will follow up with you after. The format we will follow today is a conversation between Evgeny, Tammy, and myself. Now, before I get started with introducing the agenda, we'll go ahead and have my co-presenters introduce themselves. Evgeny, please.
Hello, my name is Evgeny Lukipodis. I lead the Research and Emerging Technology Group at Rhapsody Health. My background is in applied mathematics and computer science, but I've been working for the last probably 30 years in digital health, mostly on the vendor side. I joined Rhapsody last September, and I'm privileged to work with a group of very enthusiastic software engineers that experiment with new things. And some of the things that we do, we might be touching up on today. So happy to be part of this. Tammy, over to you.
Thanks, Evgeny. I'm Tammy Jones. I'm a solution consultant here at Rhapsody Health, and my focus is on the semantic side of the house. Been working in healthcare for a number of years. I'm not even going to say it, Evgeny, because it's
embarrassing.
Right, I know. But have spanned quite a number of different types of organizations, but have been really focused on the semantic tool here for about the last 8 years. So really happy to be here. Really excited to have this conversation with Evgeny and Shelley.
Awesome, thank you both. And I'll briefly introduce myself. My name is Shelley Waymeyer, and I'm the Director of Product and Partner Marketing here at Rhapsody. So I come from a background of EHR implementation and product marketing and product management. Mostly throughout this time, I've been focused on figuring out how to get the right data into the right hands of the right people at the right time. So excited about the work we're doing here at Rhapsody to advance interoperability. All right, and for today's conversation, we'll start by first debriefing HIMSS. Both Evgeny, all three of us, Evgeny, Tammy, and I were all at HIMSS, so we'll talk through some key observations and themes. And of course, if you were there, you know on the forefront of those were topics about how AI is being applied to healthcare. So we'll speak about that and then talk about the semantic interoperability topics that we heard at HIMSS and the relationship we see between semantic interoperability and how AI is being applied to healthcare. We'll wrap up talking about why terminology management needs to be part of every organization's interoperability strategy and strategies that we use and our customers use to build a solid foundation of high quality data. So to start, like I said, let's pause a bit and talk about our time at HIMSS and what we heard. We know there were over 33,000 attendees at HIMSS in total. Our organization talked to hundreds of organizations over 3 days in our booth. And there were some topics that really stuck out from other exhibitors and on the agenda of sessions. Evgeny, would you like to share a bit about what you observed?
Yeah, well, actually, it was not surprising to see a lot of things about AI, even generative AI and everything that has kind of exploded since the end of last year. What I was mostly interested in is the pragmatic side of things and examples of how things are being applied in a way that produces results directly into healthcare. So I'll give one example. There was a health system in Florida, I think it was called the Villages Health, and they have done a very interesting project. They have actually started backwards. They looked at what would be the biggest benefit that I would get if I try to find out which are the unreported conditions that might have actually been used in our revenue stream, so that it's practically for us an unrealized revenue. So they didn't go very wide. They didn't cast a very wide net, but they just looked at the top conditions that eventually would have brought a lot of revenue, and they actually restricted it to 4. And it turned out that when they start applying NLP on the clinical notes, combined with machine learning on observations, medications, and various kinds of other structured data that they already had, they were able to discover that 15% of the cases that they looked at were actually containing such unreported conditions. And not surprisingly, they were able to identify that the peak was in, for example, degenerative neurological conditions. With everything combined, they were able to realize 2.5 million of revenue. And the interesting thing for me was that apart from combining the AI, of course, they had to put something in the data warehouse. They had to create a model that was very practical about picking up the things that already existed. So they started with the OMOP model, which is the observational model already used for a lot of analytics. And they structured their data in such a way so that the results that they got could later be used for a lot of other things. And actually, it was exciting to see the short period of time in which they were able to realize those benefits with tools that already are available there. So there's nothing, I'll say, revolutionary in new. It's just putting it all together, putting semantics together, putting NLP together, putting AI together, and ML in this particular case, with the existing models that already have been created for these kind of purposes, to be able to realize the benefits immediately and actually energize the organizations to do more of the same in the future.
Yeah, it's like you said, a pragmatic tactical use case that seems to led to them realizing revenue and improved outcomes quite quickly. We dove right into it, but maybe it's worth level setting with the audience. You know, we're talking about AI, and then we're talking about it as, you know, as it is a broad umbrella term, and there's different approaches or applications of AI that we're seeing our customers and seeing other healthcare IT companies adopt to realize these benefits. So examples of subsets of AI or generative AI, as is a hot topic right now with ChatGPT, large language models, machine learning, natural language processing. And like Evgeny said, none of these are necessarily new, but there's a resurgence to it with how quickly we're seeing it evolve and be applied. The statistics Evgeny pulled, I don't know, Evgeny, if you did a control find on an export of the HIM spreadsheet or if you counted these up, but more than 120 companies were showcasing various kinds of AI capabilities, which is an impressive amount. I'd be curious to see that trended from past years as these topics were introduced. So, and Tammy, what about you? What was top of mind for you after HIMSS? How did your conversations go on the show floor?
You know, there wasn't as many terminology or semantic vendors or organizations that were there at the show, but it's definitely growing. I did see increased sessions about terminology, that the value of it and where it's applied across healthcare. So that was such a great thing to see the increase in the sessions. Where I really saw the great movement really within at HIMSS, at the organization, at the show event, I should say, is that, you know, people came into our booth and talked a lot. I didn't get out of the booth a lot, to be quite honest with you, because people would come into the booth and have conversations and want to know about the interoperability suite and what Rhapsody was doing. We would start those conversations. They didn't necessarily start with semantics, but they landed there. It's like immediately, as soon as we start talking about interoperability, semantics enters the chat, and then off we go. So it really was an eye-opening experience. I mean, I know, just because this is where I live, is that semantics and the terminology management component are really, really essential to the foundation of your healthcare organization. And, you know, trying to evangelize that and get that message out has been something that's it's been my mission for a number of years. But understanding and seeing that people are really grasping it now and understanding and and taking it to heart that this isn't just a nice to have anymore. This really is a must have to be able to manage this effectively, to have that foundational layer, to be able to apply the AI and the ML and the NLP on top of this good, solid data foundation.
Yeah, absolutely. I know there were many times when I was having conversations on the booth, and as organizations were asking what we've been up to this last year, I was great to bring up, oh, we've now added a semantic interoperability platform to our interoperability suite, and immediately ears would perk. I'm like, oh, really? Because they're solving for issues that they see with the number of terminologies that are used across the organization, or varying terminologies or standards in those medical languages that are coming in from outside organizations. And I remember you, Evgeny, saying in passing that you attended a few sessions, or maybe read about a few sessions that were focusing on how semantic interoperability can be enabled, where current efforts are adopted, but it's not enough, right? So we have so many standards being used, and USCDI is enforcing in some of those areas, but just the sheer number and types, it's becoming a growing problem with the amount of data being exchanged.
If I can comment on that, I think that in the sessions there were a lot of focus on semantic interoperability on data, because there are very important issues to be solved. I mean, you have the US common data set, you have a lot of interpretations that you have to make, you have a lot of code systems that are involved, you have a lot of structure that needs to be put in place in order for this data to be correctly interpreted, put it like this. But Sam said something interesting. A lot of things started somewhere and ended up in semantic interoperability. And to me, one interesting area was not just semantic interoperability of data, but the interoperability between applications. And the time has gone when a single EHR or even a PACS in imaging, I have some background in imaging, was able to solve it all. Now you have these add-ons and clinical decision support tools and CDS hooks and various kinds of add-ons that actually are very specialized and do things that help the EHRs and the PACSs and the big systems that clinicians work with get extended with some very specialized tool sets. And for those to work, it comes down to being able to create the right context, and the right context to be defined in good semantic terms. So to me, it was more about like APIs and creating those APIs in such a way so that those who consume and those who provide it find the right common language. And semantics is to a great extent the answer. And I would say it's not about normalizing and standardizing, but have the possibility to have this constant transformation, because you will not be able to fix it once and then it's going to be solved. You always will have to go and adapt, and it becomes a very dynamic problem that at the end of the day, you need a powerful tool set to be able to deal with. And that was what was very interesting to me. And I projected it directly into the work that we are doing into the API gateway, which is very healthcare focused, trying to understand these constant changes that occur on the payloads and the different translations that have to happen between systems, so that that conversation that is taking place between the systems, but also between the humans that are using those systems, is meaningful.
Absolutely, and perfect timing, to a visual I pulled up on the screen that we actually referenced in last month's webinar. It's just quite relevant to the work we're doing, as we are seeing we're seeing provider organizations move workflows outside of the EHR to drive forward patient engagement, consumer 360 initiatives. So just looking at televisits, virtual visits alone, 80% of providers as of 2022 were adding a digital tool specifically for that, compared to as 28% in 2019. And then across the board, across these different types of tools or digital health applications, you see that increasing across the board for remote monitoring, clinical decision support, patient engagement, you name it. So it really tees up what Evgeny said, is that this is an evolving problem. It's not a point in time problem. There's going to be a variance in types of data being used and how it's captured, how it's rendered, how it's exchanged in and out of these systems, which then, as organizations are trying to improve operational excellence and have data-driven insights to their organizations to get a view, an analytical view of what's going on across systems, across specialties, really requires a way to make sure that data is exchanged in a meaningful way and consistently. So pulling up a few more data points here, we know operational excellence sits top of mind. We also know there's a disconnect between the desire and reality of being a data-driven organization. And I'm sure much due to the fact, bringing in applications at an increasing rate and not able to keep up with that. And we're talking about analytics, and I think of analytics as, a rung on the ladder of AI, right? It's at the most simplest definition, AI is a form of analytics, and organizations are using analytics in many ways, maybe not putting advanced algorithms on top of them, like some of those subsets we were discussing, like ML and generative AI, but the root of it, it's all analytics. Perhaps this is a good time to level set on, why we see semantic interoperability as so important to these analytic initiatives in AI. We've been talking about these terms, but we could take a step back and define them. We define semantic interoperability as the ability to exchange and interpret information using a shared understanding of the underlying data. And then artificial intelligence as the development of advanced systems designed to analyze data, learn from patterns and make decisions and solve problems. And so I quoted my friend Tammy Jones here at the bottom, who, as she likes to say when she's introducing our semantic terminology management product to customers, is we better be singing from the same sheet of music. Let's make sure we're building these analytics, building patterns and making decisions and solving problems from a solid data foundation.
Yeah, Shelley, I say that often, but it resonates. This is really something you can say, really speaking the same clinical data language too. It's the same thing. It's really just trying to understand what information is there and have it make sense. I mean, we don't want to guess as we're going through what this could potentially be, what this clinical note might mean, or this concept might mean if it's not a standard. We really want to be sure about that. You don't want to have a game of telephone that's one system says one thing and then it morphs and it passes on to something else. Let's get this standardized. Let's get this to be meaningful and have that good understanding. And that's a great statistic you have up right there, that cleansing data before training, it takes up to 80% of the time. So how can we help facilitate that? What can we do with some other pieces of AI and ML to help drive those results and leverage the data that we do have to enable you to make good decisions about what this means and what is meaningful about it? I do want to bring up too, on the last couple of slides, you talked a lot about the statistics for providers and healthcare executives and where they're going and what technology they're looking at. I think there was another study that was out. It was a recent Accenture study that said over 90% of healthcare executives and almost all, 98% of providers, agree that generative AI and advancements in that are going to be a big game changer. And most of them are planning to pilot this technology or already piloting that technology this year. So it's here, it's now, and they're really embracing that as organizations and executives. So it is coming from the top, but I think it's coming from the bottom too, because with all of these advancements in these pilots, they also recognize that about 40% of all working hours in healthcare can be supported or augmented by language-based AI. And I think the key in that phrase is supported or augmented, not replaced. We're not replacing humans in this. We're augmenting, or we're helping uplift what they're already doing. And so, taking that 80%, let's see how we can help and augment and uplift and lower that time, perhaps lower that to be something that's much easier to swallow for our healthcare professionals that are working on the data.
Definitely. This one, resonates for me as we, have been speaking with a customer who's building precision data models, and they built their architecture for cleaning the data and serving it up for development, for applying predictive models around, our semantic product, because they knew that they could not waste time. They were going to scale fast. They had a team of only 3 people, and they knew they needed to be working with the right tool set to turn over the data that they were procuring from customers and from open data sets as quickly as possible, so that they could be bringing that value to customers quickly. Definitely resonates with me. And I know, Evgeny, you had some comments when we were preparing about, how you see precision medicine and the evolutions of AI and precision medicine coming into play in a pragmatic way.
With so many different thoughts going through my head that we were talking about, and well, precision medicine was a personal interest of mine, and actually that's something that it's very interesting. It hasn't had enough attention at HIMSS, to be honest. I attended one very deep session that was very interesting, but I would have expected a little bit more. And the reason there is that practically we are sinking in a lot of data in the different phenotypes, but when it comes to things like rare diseases, you have to tap into various kinds of other data sources in order to be able to start making sense of what's really happening. And of course, you go into areas like genomics and stuff that is not so much clinical practice today. At least it's not a mainstream clinical practice today. But what I was surprised to hear is that if you take into account all the rare diseases as a cumulative, you will see that they are more common than diabetes. So practically, there's so much important to focus on that we need to deal with that. So apart from the phenotypes and the genotypes and all the data which is being collected, it's also a challenge that's a kind of a moving target. Because when you look at the genotype and the variants compared to a median, to a standard, which is always changing, so it's not a static thing. So it is like a moving target. So you always will have to keep on improving and keep on learning more and more and more. And I think that's where it touches on so many different things that what we're doing, especially in the semantic space, because it goes even beyond just the data that you're collecting about the individual cases. It goes towards even the knowledge artifacts. So the things that you are using in order to be able to make decisions. You could think about value sets and clinical guidelines and various kinds of things that practically today are, I'd say, a little bit of a Babylon Tower. And I saw it. I was in a different organization that we were investing in digital health during the time of COVID, when every single organization had their own COVID-19 clinical guidelines, completely different, not synchronized with each other. Not talking about data, I'm talking really the clinical practices. So we found it a very interesting project that tried to create some kind of a Wikipedia like of a mechanism that was able to try to standardize. And of course, you see semantics how important in this space. And the other thing that comes to mind when we talked about precision health and the amount of data that we're collecting is that, and you'll hear I'm a mathematician, so data is growing exponentially. But the information that's contained in the data is actually growing linear. So if you think about it, the signal to noise ratio is degrading exponentially. So you have so much data, but you are not making much more sense of it. You are making just a little bit more sense of it. So just as much as AI needs data, I'll turn it out and say that data needs AI to be able to make the interpretation and to surface what you really need. And I'll give the example of precision medicine. Very often, a clinician that orders a very specialized exam, could be precision imaging or genomics test or any kind of multi-omics, will not have enough information to be able to supply it with the request and with the order. So when these downstream services receive that order, we don't have that information in order to be able to make the next step. And the next step might be changing the order because the tests will need to be replaced, or getting a prior authorization because these are expensive things, and they will have to get that information from somewhere. And collecting that information normally is not even only with the referrer who is sending the order. So finding a mechanism to pull the relevant information, which is relevant to this specific case, is already a big challenge, but I would say it's a big opportunity as well. And you mentioned generative AI. So there are many use cases of generative AI, and we have to be careful with it because it was created for different purposes. It was a very creative thing. So I don't know how much we want to be creative in healthcare. I think we want to be more precise than creative. But generative AI has turned to be a good tool for creating summaries. So if I want to pull in an entire patient record and create a summary that will justify the usage of the application of specific test or exam, that's a very interesting use case of generative AI. And in order for this to function, there's a lot of, it's a semantics problem at the end of the day, if you think about it. The last thing I would mention, which is also very interesting, is that you have a slide on cleansing data and all work that goes on kind of creating the more significant pieces of data that will be taken further.
Mm-hmm.
It's important to understand the cleansing of data and the cleaning of data, whatever the term you use. It's not about removing the noise. It's about adding additional layers. And generative AI is a perfect example of this, because generative AI is trained on the internet. It's trained on everything, and that everything has a lot of noise, really a lot of noise. And I always give the examples. It's trained also on flat Earth statements, and that doesn't surface when you're working with generative AI. So it's not about removing things from the data. It's about adding additional layers. And for example, think about the value sets that you can filter through and create a very, very rich vocabulary, not removing the data, but clustering the data in pieces that can later on be made useful. I have plenty of examples. I don't think we have enough time, but I think that there's a lot of misconceptions about data, like garbage. People talk about garbage of data and removing data. It's not about it. It's about creating the right layers and surfacing the signal out of the noise in some very particular cases, because in one case it will be one type of signals, in another case it will be different type of signals. So it's not about removing what you have from data. It's about adding the additional layers that help the various applications and tools get to the right subset of the data that's applicable for the purposes that somebody else wants to do it, being it clinical decision support or analytics or something else.
Yeah, I agree with you, Evgeny. I think it's really important. We did talk about garbage in, garbage out, and that's been something that has been prevalent for years and years. And let's shift that conversation to your point. Let's shift it, instead of saying, let's remove this stuff, it's garbage. No, it's not garbage. We're going to recycle this in a different way. How are we going to categorize and put this into my plastic bucket or my glass bucket here, right? We're going to put this in recycling buckets that really filter this and make sense. And to your point, those subsets or those value sets are really important in filtering those out. Just bubble up the things that are really important to me on that rare disease, for example, and making sure that the semantics and the terminology is really applied to that data is really going to help you when you're applying those analytics to that and applying any of the AI tools that you have. It's so important to do that. So again, we're going to compare apples to apples. We're going to have that same clinical data language across the board to have that strong foundation. I think it's really, go ahead, Evgeny. I know you've got something.
I wanted to mention something that came to mind because I read it in an article, and it might sound surprising. it's an argument of adding data rather than removing data. So generative AI, which is trained on all of the internet, on various kinds of texts, medical text and normal text, performs better on medical text than generative AI trained only on medical text. This might sound absurd, but that's the case. So I think that these are interesting things to note, that they're in the argument. I would say that you need to add more layers. You need to add more layers because you don't know what you're obscuring when you remove.
Right. And just like you said, if we don't want to remove all the data, we want to incorporate all of this. And you talked about the flat Earth data, and the same thing with an air diet. What are they called? The breatharians or something like that believe you can just live on water and salt soup, essentially. Well, I mean, that's going to be incorporated into that data too, but we have to be able to filter out that noise or incorporate that data that says, this is probably not a good idea. You can't just say, remove everything that has an air diet reference to it, right? You've got to incorporate that, but take it with a grain of salt and really and understand what its meaning is, understand why it's there, understand that this is a negation maybe, or something to that effect.
Yes. This kind of brings me back to the quote we started this conversation on, which is that the slide before this one, that you have to balance the art of possible with the art of practical. And I think it might be, I don't know, good timing, Tammy, to maybe talk through, we keep referencing filtering out the data, the value sets and the subsets, to talk a little bit more tangibly about how you can use, how customers use our semantic terminology management platform to build value sets. If you want to speak through one of those workflows.
Yeah, I think it's really important to talk about those value sets, to your point about how you filter those things out. And our customers are using that to filter and to look for very specific things within the data. But again, to get there, we like to standardize that data too. So again, we're speaking from that same clinical data language, and we're referencing that. But the things that you can do when you're talking about creating a value set in a way that's meaningful for your organization, and putting these building blocks together to create something that's meaningful for you. You want specific sub-hierarchies in a code system, for example, or you want to have a specific term that you're incorporating, and building this, tying these together in almost like a Lego blocks way, to tack them together to build this grouping of concepts that are really relevant for either a rare disease or diabetes or something to that effect. And our customers are using that for reporting, quality reporting, and even sensitive data filtering as well. So how do I define the things that I need to flag in some way that could be sensitive and need to be held under lock and key, if you will, that we have to have specific access for it. So, and to do that though, like we talked about before, we really have to get it to a standard, because all of these systems are saying something different when they're sending data in. That, it could be from a clinic's EHR, a hospital EHR, anywhere else, they're sending something different. There's zero chance out there that all of your sending systems are sending the same version or the same coding on it. They have something unique and proprietary. They have their own way of speaking this language. So let's get it together. And having a tool in the middle, like our the Rhapsody semantic tool as part of your interoperability suite, is the value here, is the real value add, and being able to clean that data, really filter this, clean this, put it into the right recycling buckets, if you will, to be able to make sense of this data and surface the things that are really important to you, and settle down that noise just a bit, getting it all to the same equivalency, if it's at all possible to do that.
Awesome. Well, thank you for talking through that example. And at the core of it all, right here at Rhapsody, it comes back to integration. And as our customers are deploying semantic terminology management, Rhapsody semantic into their environment, it comes with over 100 APIs out of the box to connect to data lakes and to downstream systems that tee it up, whether it's going to a dashboard for reporting or going to a development team to layer on their AI models.
Yeah, some of that, I should really talk a little bit too about, and I know, Shelley, that we've talked about this before, but just because we apply AI models on top of what we do with the semantics doesn't mean that we don't have our own internal as well. So I think those are important pieces too, that we're embracing the artificial intelligence and machine learning aspects when we're applying our own algorithms on top of that data as we're going through some of our mapping processes. And those are things that we can utilize and leverage and help our customers to identify some of the gaps that they might have within their data. They maybe don't even know that they have either. And so things like we can do a data assessment from their data as it comes through and take a look and see what's there, see what's non-standard, and how we can help them get that to a standard code system, whatever that might be for that data flow, get that to a standard so they can really make sense and make use of that data to its highest extent. And those are things that we're doing for our customers now that have proven to really drive that conversation and have that value add for it to be able to help our customers on their interoperability journey.
Awesome. Yeah. So what I heard you speaking about there is, in addition to teeing up a solid data foundation for development of AI, we're also applying AI in our own ways to automate mapping. So our end users, the data scientists that use Rhapsody Semantic, the clinical terminologists that use Rhapsody Semantic, have the flexibility and adaptability in the tool to create their own mappings and even create custom terminology sets that serve their purposes that can be mapped to or from standard preloaded standard terminologies. But we also have the ability to do some automation in there so that it can learn from past mappings and generate those going forward with increasing accuracy.
Absolutely. And Evgeny, you had something you was on the top of your mind there.
Yeah, when you say, I just wanted to add, I really like the way that have positioned semantics, because it is helping the organizations to add those additional layers, not to remove them, to make sure that they actually are allowing the multitude of different uses to be accumulated. That's why I have different mappings, different code systems. And about normalization, there is a reason why a certain system uses a certain code and code system, even if it is proprietary. So we don't always have to force them into a normalized way of working. It's being able to put those layers so that they continue working on how they used to work, but constantly evolve and constantly improve. And I can say, because I'm working on the emerging side of things, is in an ideal world will be that the semantics product will be shared by all customers. And instead of everybody creating their own sensitivity data sets, those are shared and those are built on top of each other, of course, with the right controls and everything. So we do have at least the tools to be able to make this much more collaborative, because that's where the value of AI is, when it's not siloed, but when it's the union of different things.
Yeah, absolutely. Exciting to think what we can do with the technology we have to create those efficiencies in the future. So, all right. Well, any remaining thoughts, any questions from the line? Doesn't look like we have any right now. So we want to thank you for joining us for the webinar today. We are excited about what we're building with customers with the interoperability suite, cornerstone of that being our ability to transform data with the semantic terminology management solution. We have some exciting stories we'll be sharing soon from customers that are using it to drive their development of AI models. And we look forward to sharing those on upcoming webinars and in our case studies. So hopefully you're following our newsletters so you can stay informed for when those come up. Any remaining thoughts, Evgeny or Tammy?
I think you had an interesting slide at the end, and I think that that's where I wanted to make that point of the APIs. It's
Oh,
the
yeah.
world of the world of APIs today. It's not so much about one system being able to do it all. It's you see it everywhere. And I would speculate on that slide before that you have the digital tools that maybe the reality is even much more extreme. There are a lot of things that are not accounted for. There are a lot more tools, digital tools that are used that are not on that graph. Because it's not possible for a single system to solve it all. And you see it already in all the different workflows. It's sometimes it's very apparent. It is inside the workflow of a clinician that has to use those tools, but sometimes it's behind the curtains. A lot of things are happening without even being noticed. And this is where the API gateways and the APIs and the payloads being transformed constantly into meaningful results that are passed through is crucial to not just the single healthcare system, but to the entire digital health ecosystem, I would say.
Yeah, I agree with you. And you know, when we talked a little bit about this is more, needs to be more precise than creative for what we're doing in healthcare. But I also think that our customers are looking for the art of the possible too. What is possible? What can we do? So to build on that, we have to have something solid on the ground floor, really that foundational layer of the solid semantics to build on it. And what is possible once we have that? Once we have the good data foundation, what's possible from there? And I know we referenced an article about, you know, the art of the possible, and I had a client conversation that they brought up that very specific quote. What is going to be possible? What's the art of the possible? That's what we're looking for. We're looking for that now. So I think everybody is incorporating and bringing in all of the things that they're seeing with all the generative AI, the large language models, all of those things, and they're opening their eyes to it. So we want to be here to really be able to focus and to help them achieve whatever's possible out there with the data that they have.
Absolutely. I feel like we could keep talking, but that's a good thing because we have
Yeah.
a second occurrence of this. It's really what I love the points that you both made about, and I think this holds true across our entire interoperability suite about how we can meet our customers where they are, meet our users where they are. We don't need anyone to change how they're doing anything. Do it the way, unless they want to, right? Like do it the way that's most intuitive to your workflow, and let's take care of that data and protocol standardization on the back end. We've got the tech and the tools to accommodate what's best for that end user. So, I guess on that note, we'll really wrap up and we'll continue this conversation in a few hours to hit our friends in the APAC region and on the West Coast.
Thanks, Shelley. Thanks,
Yep.
Evgeny.
Thank you, Sherry. Thank you, Tammy. It was beautiful.
Thank you.